So let's think about what happens if we flip a coin not once. So all of this stuff over here was what happened if we did it once, okay, and thinking about the probability. Now let's start thinking about multiple events. So what happens if we do it more than once? So in this case, what are the possible outcomes of flipping a fair coin 2 times, twice, okay? Now there's 3 ways that I think we can represent this, okay? First of all, we can represent it just simply as a list. So if I say H represents heads and T represents tails, let's not consider what happens if we get an edge coin because that's pretty unlikely. So there's only 2 outcomes. This is my sample space, okay? Let's list all of the different possible outcomes that we can have if we flip a fair coin twice. So what could we have? Good. So we could have heads and heads. Heads and tails, perfect. Good. Tails and tails, okay? Now, are you happy that these 2 things in the middle are different? What's the difference between them? Because that's got heads and tails, that's got heads and tails. What's the difference between them? Absolutely. Absolutely right. So in this case, heads and tails does not mean we get a heads anywhere and a tails anywhere. It literally means we get a heads on our first throw and a tails on our second throw. Okay? So if you like, you could number these. You go H1 and H2 to represent heads on the first throw, heads on the second, and then 2, 1, 2, 1, 2, just to make it extra clear. You don't have to, but it might make it a little bit clearer. Make sense? Good. Another way you can represent this is using a dot diagram. A dot diagram. Has anybody seen one of these before?
I think so.
Okay, so it literally is just a table that represents the different possible outcomes you can have on each throw. So let's represent the rows as our first throw. Okay, and let's represent the columns as our second throw. Now, what are the possible outcomes on our first throw? Well, heads and tails, aren't they? For our first throw, we can either get heads or tails.
Oh,
okay. What are the outcomes on our second throw? Heads and tails. Okay. So can you see here that just simply by drawing a dot, we can combine these 2 events together? Okay. So for example, that dot there would represent getting a heads on our first throw and a heads on our second throw. Make sense? What would this dot here represent?
Heads and tails.
Heads on the first throw, tails on the second. What would this dot here represent? Tails and heads, tails on the first, heads on the second. What does this dot here represent? Tails and tails. Absolutely right. Does that make sense to everyone? Okay, so this is fine. But can anybody think, what are the limitations of these 2 methods? So first of all, what's the limitation of this method? So just listing all the different possible outcomes.
I don't know if there is a limitation.
Why won't you miss some of them? Yeah, absolutely. So this wasn't too bad, okay, because there's only 2 possible things that could happen, right? So actually the sample space for flipping a coin twice is pretty small, okay? But you can imagine as we increase the number of outcomes, we increase the sample space, this thing is going to get pretty big, which means that you really need to think it through logically in order to make sure you capture any, okay? And also you might have a situation where you have sort of thousands of outcomes. You have thousands of outcomes. This then starts to break down because it's just going to be too big. Yeah, you're bound to miss some. Okay, there's no logical way of doing it, right? So that's fine. So listing outcomes is okay if the sample space is small, but if it's too big, it becomes difficult. What are the limitations of a dot diagram, do you think?
No idea.
Okay, so what about if I now throw the coin another time? How do I represent that on a dot diagram? We'll add it where? Because we've used the rows to represent the first throw, the columns represent the second throw. Where are we going to go now? Right? So unless we can have like a 3-dimensional table, that's going to become more difficult, right? So actually writing it down on a bit of paper, we're only limited to things which can happen twice. So multiple events, well, that's fine as long as we can only happen twice. I mean, I guess we can kind of be a bit more clever by thinking about, well, okay, this can now represent the first and second throw outcomes, but it becomes more difficult. You happy? So my favourite way to represent outcomes which happen again and again, so multiple events, is using a tree diagram. Okay, so let me talk you through this. So what I'm going to do is I'm going to represent the first set of branches. So the first set of branches will represent my first throw. Okay? Now can you tell me, so each branch represents an outcome that could happen. What are the different outcomes that I can get on my first throw? Yeah, heads or tails, okay? So I'm going to draw a branch and then another branch, and this represents a direction which my experiment could go in. Either I could get this one, let's represent that as a heads, the top branch represents heads, and the bottom one I'm going to say represents a tail. Okay, so I can either get heads or a tail. So the 2 branches or 3 branches or 4 branches or however many branches I have represent all of the different outcomes that I can have. Does that make sense to everyone? Okay. But then if I want to go and do a second throw, I just increase the number of branches. So, okay, let's suppose that on the first throw I threw a head. So I've gone in this direction. What can then happen on the second throw? How many different possible things can I have on the second throw? 2, right? So I'm going to draw another set of 2 branches like that. And again, I can get either a heads or a tails. Yeah? But let's suppose, let's trace ourselves back. Let's suppose instead I got a tails on the first throw. What are the different outcomes I can have on the second? Exactly. Okay? Now, are you happy that this thing here is very different to this thing here? Okay? So this here is very different to this here. Why? Exactly. So now what we're talking about is this idea of dependence. Okay? So in other words, this thing here says you're getting a heads on the second throw, but only if you get a heads on the first throw. Whereas this one is saying you're getting heads on the second throw, sure, but that's only happening if you get a tails on the first throw. Does that make sense? Okay, good. So usually we put the different outcomes on the end of the branches, and the probabilities go on the branches. So for example, what is the probability of getting a heads on your first throw? It's a half, right? It's 1 in 2. What's the probability of getting a tails on your first throw? 1 over 2. Now you notice that all of the probabilities on the branches have to add up to 1. Now what does 1, do you think? What's 1 correspond to in probability?
Like one side?
Exactly, 100%, so it's certain, okay? So in general, 0, a probability of an event happening, if it comes out as 0, this means it's impossible to happen. Whereas if we have the probability of an event happening to come out as 1, that means it's certain. So you remember that number line which I got you to fill in at the very start? From impossible, likely, fair chance, very likely, and then certain. We can now transcribe that into 0 to 1. Okay? So in other words, if I put this along a number line, okay, whereas before I had impossible down this end, now what I can do is convert that impossible, those words, into numbers. That would be 0. Yeah? And then likewise over this end, where I've got certain, I can transcribe that into a number which is 1. And obviously everything in between. So a fair chance would be 0.5. Likely chance would be something like 0.7, 0.8, something like that. And 0.25 would represent an unlikely chance. Does that make sense to everyone? Yeah, does that make sense? Okay, good. So again, I need probabilities on these branches. What's the probability of getting a second heads on the second throw? 1 over 2 still, yeah? And that's a half, and that's a half, and that's a half. Now, are you happy that these probabilities are actually independent of what happens here? Okay? Yeah. Because these are independent things, right? Getting a heads on your first throw is not going to affect the probability of getting a heads on your second throw. Yeah? But this still comes in useful when they are dependent. Yeah? Because you can see how the probability change quite nicely. Good. So let's think, what is the probability of getting 2 heads in a row? What's the probability of getting 2 heads in a row? So what's the probability of getting a heads followed by a heads?
Is it 1 over 4?
It is 1 in 4. Now actually we'll come back to this in just a second, but you can really easily see it from one of these 2 things. Okay? Because a heads followed by a heads is 1 out of 1, 2, 3, 4 outcomes. Does that make sense? Yeah, 1 in 4. Now here's my question. Heads followed by a heads. Heads followed by a heads. We're looking at this outcome here. Okay. How do we get 1 in 4 from these 2 probabilities? We times them. If you add them together, you get 1, don't you? Half plus a half is 1.
Oh, yeah.
Yeah? So we times them together. Okay, so this would represent a half times by a half. Does that make sense? Okay, so if you want one thing to happen and then another thing to happen, so if you want one thing to happen and another thing to happen, you end up multiplying the individual probabilities. Okay, now have a look. What is the probability of getting the same face on two flips of a coin? What does that mean?
Getting like heads or tails twice when you flip the coin twice.
Exactly, so either get heads or heads or tails and a tails. Okay, well look, we've already considered heads and heads. We can also consider tails and tails. Okay, so this would be tails and tails. Okay, what are the chances of that happening? 1 in 4 the same, because you take a half and you multiply by half. And you get 1 over 4 again. So now I can answer the question, what's the probability of getting the same face? What is it? It's a half. Why is it half? Exactly. Now we've got these two probabilities here. We know the probability of getting 2 heads in a row is a quarter. Probability of getting 2 tails in a row is a quarter. Okay? It should come out as a half. Okay? You can also think about it like this. This is 2, these are 2 out of the 4 outcomes that could happen. Yeah? If I do it here, 2 out of the 4 outcomes that can happen, which is a half. Okay? But you're absolutely right. If you want to combine together a quarter and a quarter to get a half, you're going to have to add them together. Does that make sense? So in other words, we can say, if you want them both to happen, you should end up multiplying the two probabilities. If you want one thing to happen or the other thing to happen, in other words, they can't both happen at the same time, like you can't get heads and a heads and a tails and a tails if you only flip the coin twice. You're going to get one or the other. You should add those two probabilities together. Is that okay with everyone? Good, fantastic.